Hi everyone. So something slightly different this week. So this week I had to do a competition in front of teachers, school children, university students that was to do a scientific Christmas talk. Now what I did was to make a scientific Christmas tree. So I did all the different scientific decorations and things like this. And it was all recorded. And I have all the recordings. So what I'm going to do is I'm going to, in this video, just show the recordings of the entire talk. And I'll put the slides up as well so you can see those. So it's something slightly different, but I hope you enjoy.
So, hi everyone. So Christmas is a time of magic and of wonder and mystery and elves, and a strange man that breaks into our house every year and leaves us Christmas presents. But we're scientists. We want Christmas to be much more scientific. We want some science to be in our Christmas. So what we're going to do is we're going to take the true icon of Christmas, the Christmas tree, and we're going to make it a bit more scientific. So here I have my scientific Christmas tree. As you can see, it looks incredible. It is just a clap stand that you use to hold beakers and test tubes of Bunsen burners. It's maybe not as beautiful as a Christmas tree, but it definitely does sort of represent our scientific Christmas tree. And I have all my Christmas decorations on here as well, and I'm going to go through them and show you what our decorations are. But first things first, the best part of any Christmas tree, and the fundamental thing you need to have, is the tinsel. So what I have here is I have my tinsel, which is this multicolored thing around the outside. Can anyone shout out what they think this represents on our scientific Christmas tree?
DNA?
Yay! DNA. Okay. So, our tinsel is represented by DNA. So if you know what DNA is, it's the chemical in our body and our cells that tells them what to do and what we look like. Here's an artist's impression on the right hand side, and this is an actual picture of DNA. And what it is it's two sort of branches and lots of strands in between, and it's twisted round in something called a double helix shape. You can kind of see the shape here in this image. So this is what our Christmas scientific tinsel will look like. Now next thing is what you need is you need some kind of bauble decoration on your Christmas tree. Baubles and bells, they're boring, they're not scientific. So what I have here in these small vials here, is you can see liquids of different colours, and there's two liquids in each one, and they're red and yellow and green and yellow. But you might be wondering why these liquids don't mix together. What have I done to make them so special? Well, what I've done is I've used liquids of two different densities. So I use a really dense liquid, which is washed up liquid, and a less dense liquid, I use water, and I tied it red and green. And I put them together, and what happens is the dense liquid goes to the bottom, and the less dense one goes to the top, so they separate. So we can now make our scientific kind of bauble decorations by using different coloured density liquids. Now next thing, on top of your Christmas this year, you may have a star or you may have a fairy, but I'm a scientist and I'm afraid to tell you that fairies don't exist. And neither do stars look like this, which is what you normally have on top of your Christmas tree. The sun at the centre of our solar system, it's just a normal, regular, boring star. And this is what stars look like. They're big round spheres of bright gas in the centre of the solar system and in space. So what I have is I now have a representation of a real star. This is what a real star should look like. It should look like a sphere. You don't want these rubbish white-winged stars. A real star looks like this. Now, so I really want a Christmas atmosphere on our Christmas tree as well. And to do that, when I think of Christmas atmospheres, I think of things like snow, I think of cold, and I think of mist and fog. So I really kind of want that on our Christmas tree. So what I'm going to have here is these little beaker sort of jar things here are full of just cold water, and I'm going to use, oh no, there's no liquid nitrogen left.
Sorry.
Oh, there is, there's a lot. There's a secret closet of liquid nitrogen. I'll put goggles on for your safety. So what happens is this liquid nitrogen is really cool. It's minus 100 degrees. And what happens is when you mix it with water, it warms back up and goes from the liquid nitrogen back into the gaseous form of nitrogen. So if I put this in here, you should see is that we have a kind of fog mist effect on our Christmas tree to make it a little bit more Christmassy. So we have one final thing that every Christmas tree should have, and that is, of course, Christmas tree lights. But we're scientists, we don't want to use boring bakers or batteries and things. We want to do something really exciting. So we're going to use potatoes to power our Christmas tree lights. Now, there's an acid inside potatoes. When you put two pieces of metal on the inside of the potato, the acid conduction generates electricity. So what I have here is a giant tray full of around 20 potatoes, which you may be able to see. And I've connected them all up with wires. And so hopefully I can now turn on these Christmas tree lights and it'll look good. Before I do that, this is my scientific Christmas tree. We have our accurate star, we have our mist and fog, we have our baubles, different density liquids, and we have our DNA tilt. So if I now do the lights, those don't make incredibly good batteries, but they do kind of work. So fingers crossed. I hope you can have a scientific Christmas as well. Merry Christmas, everyone.
Thank you very much for watching. I hope you found it interesting. I think it's a kind of fun, slick video around kind of Christmas time. It's still scientific, but slightly more Christmas humorous kind of nature to it. Don't forget to like and subscribe and leave comments. I really, really appreciate it. But otherwise, thanks for watching. Check me out on Twitter at UKAstroNut, and I will see you all soon.